All right, I'm Eric. I work at Pinterest on Android things, and we're going to be talking about upgrading to Moshi. Who here has at least played with Moshi a little bit? Okay, cool. So lots of new things. Who here has used Gson before? Okay, cool. So a lot of this is going to be kind of talking about the upgrade path from Gson to Moshi. And I think even if you've used other serialization libraries, you'll get a lot out of it. But there's like a lot of specifics around Gson we'll also be covering and kind of that specific upgrade path. So what's Moshi? It's a JSON serialization library for Java. We probably all know that. A couple of the design goals that Moshi really tries to hit here are succinctness, so that you can look at the API, be able to sit down and in 45 minutes to an hour, be able to understand how to use it, get it integrated in your app, get working with it, let it do what it needs to do for you. But that's also kind of a conflicting goal, as every library kind of runs into, of being able to be a very powerful library, have powerful APIs, let you be able to implement your complex use cases. So that's kind of always the conflicting goals of any project. Moshi tends to err on the side of simplicity of an API and providing just the bare bones APIs so that you can build more frameworks off of it for your specific use cases. And we're going to see how it kind of takes the opposite approach from Gson, or maybe just the more thoughtful approach over Gson. So I say for Java, it also works with Kotlin. You have to stay until the end until I really talk about this. But we're going to be talking about the interop and what Moshi is doing to support Kotlin. And it's something that if you're on Gson, you're kind of stuck with. There's some limitations in like Kotlin data classes that you're not going to be able to use. Jackson, I know, has some support for Kotlin, but if you're coming off Gson, it'll be a welcome addition. So yeah, Kotlin. Why update from Gson? So I've kind of like bashed on Gson here, and like I want to give context. Gson is a library that has been through a lot of evolution and has not found active development. It's the maintainers have all left Google. So Ender, Jesse, well, coincidentally, Jake is now back at is now at Google, but it doesn't have a proper maintainer. There are a lot of features that just won't be implemented in Gson. Gson probably won't have another release. If it has another release, it'll probably be the last one. And it has a lot of bugs that just won't be fixed. So Moshi is Gson 3. It's Gson with a more succinct API, the bug fixes that couldn't go into Gson. If it were just Gson 3, the thing is, a lot of us probably would never be able to update. A lot of internal systems in Google would never update. There's just too many breaking changes that needed to happen between Gson 2 and Gson 3 to be able to actually make that switch. So Moshi was born, and it's by all the friendly developers you already love. So when I'm bashing Gson, I'm not bashing the Gson developers. They very much know that that is the state, and that Moshi is the next evolution here. Gson, as I mentioned, is too lenient. By default, the document level API sets your JSON readers to lenient, and there's really no way around that behavior. It has broken date parsing. It lets you, in the object mapping API, you can try to deserialize platform types and serialize platform types. It has a lot of footguns in that way that Moshi kind of overcomes and provides better defaults so that you can know when there's a problem, say, with your server and let your server team know about it. Moshi also, of course, strives for a smaller API. The problem with larger APIs is they're really powerful in general, but they provide ambiguity in a lot of cases, and Gson has a lot of this where there are multiple ways of doing the same thing, accomplishing the same goal, and then you have to look into implementation details to know which one is the more performant and when to use one API over the other. And it provides ambiguity. It's harder for a new developer to come into a code base and learn how to use that library. So Moshi tries to provide just the bare bones APIs that cover the 90% use case, and then you can build the systems you need on top of it. Gson also has some inconsistent exceptions. I think it was Gson 2.4 actually a long time ago now, but provided better exception messages, but the types of exceptions can be a bit surprising. You'll get runtime exceptions where you might have expected IO exceptions in Gson, and Moshi just simply gives you an IO exception when there's an IO problem, and a JSON data exception, which is a custom type in Moshi, when there's actually a mismatch, say, in your expected types. So it's much easier then to catch these exceptions, to know when to log them, know when there's a server problem, know when there's just a data mismatch, and correct your problems faster. There's another reason. I'd say this is the least compelling reason, but it might be compelling for your use case or maybe to sell it to managers or something. The deck size that it's going to add. Gson has, so there you can see it's about 188 kilobytes last I checked. Will go into your final deck size. Moshi's slightly smaller. The method count here, again, it's about half. This assumes that you're already using OKIO, which you already are if you're using OKHTTP, Retrofit, etc. So most of the methods that Moshi is actually using are just in OKIO, so that's how it's able to really have half of the method count. So, but most likely, 700 methods isn't really going to drive you over the dex limit or say, oh, I don't have to ProGuard anymore. So, but maybe if you're near the limit, that's compelling. Also, and what I'll cover a little bit is Moshi's optimizations and API niceties. So Moshi has some performance optimizations. I tend to be a person who sides more on nicer APIs over optimizations, over performance optimizations, because the majority of what we do is read code, and knowing what it does eventually saves us more developer time, and especially when we're deserializing over the wire, a lot of that performance you might not necessarily see in real life as pulling bytes off the wire anyway is a very long process. So the actual optimizations aren't necessarily fully compelling. So the optimization that maybe is the biggest here is that because Moshi's built on OKIO, the bytes library, you can share buffer segments, or it does share buffer segments with other OKIO users. So if you're using OKHTTP, which you are if you're using Retrofit, and basically in any modern Java application or Android application, so you can actually share the buffer segments that are coming across with Moshi and not have to copy around a lot of extra data. Also, you can avoid a lot of string allocations by using a new API in Moshi that's based on OKIO's Options API, and it's just similarly called Options. It's in JsonReader Options inner class. So this is a bigger deal if you're deserializing lists and you got a lot of names and and you have to allocate strings and then garbage collect all those strings when you're done as you're deserializing. So all those field names in your classes, that it's just wasted GC turn. So if you can pre-allocate, and we're going to go over this API a little bit, you can pre-allocate into options and save yourself a little bit of again GC churn. So we're going to go over the how to upgrade. A lot of this talk is a little bit of advocacy, like the why. A minimal part of it, I would say, is actual API overview, because again, hopefully the API is nice enough that everybody can just go read the API and you don't need to come see a talk about just the API. And then the how. A lot of tricks that I've run into upgrading projects that I've worked on. A lot of like surprises maybe if you're coming from Gson, and a lot of tricks that can save you some headaches, and also a few of the things that are maybe just not in the API that would be great to like get feedback on from people in the community and people with more use cases. The first thing I think maybe some people run into coming from Gson is Gson has this field naming policy API. This is what I would say very bad. This is the thing that happens when you say, hey, Gson, I want all of, I'll have all my Java models as camel case, but all of my JSON I know is going to be snake case. So can you just apply a snake case field naming policy to everything? The problem here is that it breaks grep. When your server team goes and looks through the Android code base and they're looking for that field to say, hey, can we like remove this field from your API response? They're going through it, they're grepping, and they don't see it. They're like, okay, we can go ahead and remove this. It's really bad. And so for searchability and even for readability becomes a bit of a problem. So Moshi just doesn't have anything for this. If you need something like this, then you'll need to actually copy over and make custom, copy over the class JSON adapter and integrate the custom logic yourself. So on a similar note, serialized name doesn't really break grep. So serialized name is the annotation you put on your fields in your Java classes that you want to be reflectively deserialized and serialized with Gson. So here you're explicitly stating what the name is in your JSON models rather than the actual Java name. So Moshi does have this because there's a lot of cases where like you can have spaces as your keys in your JSON models, and of course you can't have those in Java. So there is the @JSON annotation. You can apply this to fields. And I would warn, my opinion is that this is not super great. I think you should actually just name your JSON, your Java model is the same as your JSON models. And so this might be like at first offensive to Java programmers. Like my Java code always uses camel case. Why am I going to start throwing in snake case or kebab case into my Java code? But as Android developers, we already do this in some cases, like your resources in Android. They're typically they're defined in XML, and in XML you do snake case, and you reference these fields as constants in your Java code all the time. So, and it's actually a good thing for readability, because you see, hey, the domain of this resource that I'm accessing is actually back in this XML file. So if we actually name our Java models and map them directly to our JSON models, we have to think about it as application programmers. Hey, this actually represents JSON. So when you're actually using that model class, you remember, hey, this field maps directly to this JSON. And similarly, Jesse has a post there on why your strict naming conventions are a liability in your programming languages. So I recommend reading that, and of course I'll have the slides after. So the streaming API in JSON, is JsonReader, JsonWriter. The great thing about this is it's really a pretty good API, and it's almost completely the same in Moshi. For the vast majority of use cases, you're just going to change your imports, and you're done. There are a couple bonuses that Moshi actually adds on top of this in its streaming API. So, like I mentioned, there's this options API, which will help us when deserializing. And there's also this handy setFailOnUnknown, which will help us while debugging. And I'm going to go over both these briefly. So the options API, as I mentioned, is an optimization. You simply pass in the keys, simply pass in strings into the options API. And then when you query the options with JsonReader select name or select string, depending on your use case, like if you're selecting the actual keys or if you're selecting values, then this API will return the index of the index of the array of the string that you passed into the array into options. So this way, you've only allocated the strings when you were creating options. Now you don't have to keep on allocating them while you're trying to deserialize. setFailOnUnknown is a really handy API while debugging. This is not something you're probably going to use in production code, and I'm going to explain why. So this says anytime that the JSON reader tries to skip a value, throw a JSON data exception. You're saying I've missed some data in my JSON, and I should have been reading that. I should have been using that value, not skipping it. So this is handy when your server team, you're working on a new app or something, or a new feature, and your server team is coming up with the API response, and it has like a bunch of new fields, and you're like using a previous version of the API, and you didn't know that your server team had added in some new field, like it added in the user gender or something into your user model, and you should be using that instead of like parsing it out from somewhere else. And so if you set FailownUnknown, you'll say, oh, I didn't ever use this gender field, and I should be using that in my model. So you set FailownUnknown true, and you'll just get, and then when you try to skip over a value that you didn't notice, you'll get a JSON data exception. So don't do this for production, because if your server ever updates and adds more data into your JSON structures, and your app then doesn't know about it, it's going to crash, or it's going to throw a JSON data exception and probably either crash your app or, hopefully show some failed loading state or whatever your application logic happens to be. So the object mapping API, this is also known as like data binding, but I tend to refer to it as object mapping. This is what we probably mostly use as like high-level application developers. This is the type adapter API in JSON. Basically the analogous API is the JSON adapter. It's almost the same. It's a really good API. It allows you to stream. The API that Moshi gets rid of here that you might notice is the JSON serializer and JSON deserializer APIs in JSON. Even if you're a JSON user, you should not be using the JSON deserializer API. The problem with it is it actually buffers the whole value and doesn't allow you to stream. So for performance reasons, obviously, you should be, even if you're going to stick with JSON, you should consider switching to the type adapter and type adapter factory APIs. Moshi provides no direct correlated API to JSON serializer. So there's also no document level API in Moshi. So that's basically, if you use JSON, that's the from, like JSON.from JSON, and then it'll assert that you actually consume the whole JSON document. So if you actually need that assertion in Moshi, it's one of those things that you should build yourself. There just isn't a common use case for that assertion generally. So in JSON, you had the get adapter, Moshi, you get adapter. The thing you'll notice here is that JSON has this type token API, and Moshi just uses a java.lang.reflect .type API. We're going to cover that in just a minute. But kind of the common pattern you'll see here is that Moshi, again, favoring a smaller API, tends to prefer APIs that you already use, that aren't specialized to the actual code base. So JSON has a lot of this with like type token and in its own type, like kind of type system. Moshi just knows about the Java type system, doesn't provide an abstraction around it. So cache your adapters. This is kind of an anti-pattern I see a lot actually, just that maybe JSON didn't, the API didn't lend itself to encouraging. So Moshi really encourages you to cache your adapters. So internally in Moshi, Moshi will actually cache some of your adapters, but it's wasted computer time to rely on that to happen. It's really just there so that like inner fields like in your class models can be cached. But if you already have your adapter, you should be caching it. Creating an adapter should be the expensive part. So when you have your factory, when you have your type adapter factory or your JSON adapter factory, you can spend as much time, or a reasonable amount of time creating the adapter. But after you've created the adapter, try to cache it in your application code and reusing it, because you want your adapter to be fast when deserializing and serializing, but creating it can be more expensive. Moshi provides object mapping with fewer footguns. I haven't noticed any footguns. If you see footguns, hopefully you can raise an issue and hopefully the API can be better. But one of the big, I'd say, things where you could shoot yourself in the foot with JSON was allowing you to deserialize and serialize platform types. So if you've ever kind of been in a largish application, you probably noticed that JSON allows you, provides a built-in adapter for java.util.date. But there's so many different ways of deserializing dates, and your server might not agree with the default date type adapter in JSON. So you should provide your own date adapter. There is an artifact that you can use from Moshi to install a common date adapter. But then more importantly, things like point in Android or any platform type that's like in Scala or Kotlin or Java. The main reason you shouldn't be relying on defaults here and relying on the reflective API is because you encode implementation details into your adapters. So let's say you've serialized your point class, and the point class has a bunch of internal implementation detail. It's got a bunch of fields or something, and so you've now serialized out all those fields, and then your user then upgrades his Android device, and the point class on SDK 30 has changed its implementation details. The fields in it are different. It has the API stayed the same, but the implementation of it has changed. So now you have a type adapter that was relying on those implementation details, and when you go to deserialize, it's not going to deserialize correctly. So Moshi says any platform types, you need to be explicitly providing the type adapters for this. Moshi's not going to try to make adapters based on the reflection within these classes. Another common one I see is array list. If you're using array list, just use list. Moshi provides for abstractions of collection, set, list, and then of course strings, object, map, and primitives. So Also, handy factory methods for object mapping are these JSON adapter wrappers. So on JsonAdapter, you can call serialize nulls and get a JSON adapter that'll serialize nulls. You can call null safe to make your JSON adapter null safe. Lenient for lenient parsing. Again, lenient is not the default, so you need to opt into that. You can make an adapter. You can easily, so with this factory method, you can easily make an adapter that will indent when writing, so that you can pretty print things. And then FailoNUnknown, which again just delegates down to the JsonReader's FailoNUnknown API. And so, as I said, Gson provided some APIs that weren't performant. They don't stream, they buffer. So even if you're on Gson, don't use these APIs. Prefer the type adapter APIs. So type adapters, like I said, the factory API, basically the same. We're going to see a quick example, but the API, again, like everybody can read API documentation, and it really hasn't changed. So type token has been replaced with really just type factory methods. So there's a new, you'll see this utility class in Moshi called types, and it provides things like get parameterized, and there we can get a list parameterized with string right there, and basically the same as Gson, but without the extra abstraction of the type token API and needing to learn a new whole type. You just use the Java reflection type. So here's one of those tricks that might be surprising when upgrading. Object mapping enums that you weren't expecting. So this can happen, say, if your server updates. So we have like exercise, and our application knows about some types of exercises, but our server's updated and it says, I've got this new type of exercise, jogging, and your application says, well, I have an enum, it only handles these types, what do I do? So in Gson, this is broken behavior. But it might be broken behavior that you're relying on. This is why, like, we can't just fix this behavior in Gson. So in Gson, it'll actually just say, okay, if I failed, return null. That's like, so obviously for a lot of reasons, like, that's probably not what you're expecting. Null could mean a lot of things there. And there's also no way of providing just a default, like saying an unknown exercise type. So Moshi doesn't try to handle this. Moshi says, if you give me an enum type that I don't know about, I'm just going to throw a JSON data exception to be consistent, because it's data that I was expecting of one form and it's not of that form. So that's good. It's the correct behavior. But that's like tough if maybe your API, if your server response is updating with new types, but you still want the type safety of enums. So what we really want here is maybe a default. This doesn't exist in Moshi yet. This is kind of one of those things that needs more feedback from the community. We need to hear like more use cases. For now, I have a link to an implementation of an enum JSON adapter that allows you to provide a default value. But it might be nice to have a Moshi API for fallback enums. My opinion and my guess is this API would look something like when you're building your Moshi instance on the Moshi builder, you say add a fallback enum for this enum class, and then the Moshi builder will internally create an implementation of an enum JSON adapter factory that will fall back when it fails or when it doesn't find that type. So yeah, like submit your use cases, let me know after, etc. So object mapping with JsonQualifiers. Gson makes this kind of tough. We have use cases where like we have a hex color, and so our server says I'm going to send it back as hash FFF, but Android only understands colors as ints. So we want to be able to deserialize that into an int. Or maybe we have, like in this example, a string that's actually like wrapped in another empty object. JSON makes this kind of tough to do. There is, again, like yet another API that's at JSON. It's an annotation at JsonAdapter. You can annotate fields for the reflective API to be able to handle. And this has problems because it's very the precedence, the order of that the factories, the type adapter factories will be called, is very hard to get right and very hard to understand. Moshi actually has a much more powerful API, which just lets you set type qualifiers, like similar to if you're like a Dagger user, or really in a lot of libraries have this notion where it's the same Java type, but I want you to consider it different. It's used for a different reason. So in here we say this is a string type, but it's a wrapped string, like it's wrapped around another object. Moshi, can you please handle this differently? And so this is what that might have looked like in JSON. We have to make up our whole type adapter, and then we have to annotate our fields with it. In Moshi, we can just make a separate JSON adapter for this JSON qualifier, and we say, hey, go ahead and basically unbox this wrap string in this example. This leads me to another really cool feature of Moshi. As you might notice here, this class that I'm saying is a JSON adapter doesn't like implement JSON adapter. It doesn't extend JSON adapter. It doesn't implement the factory. So what is this class? Why does it still work? So Moshi has easier JSON adapters, so you don't have to write out all of this code. So in this example, I'm first going to show what a JSON adapter factory looks like if you were to write it all out in Moshi. And basically, it's the same if you're using the type adapter factory in JSON. So you have to first check that this is the right type, and then you have to say, hey, I can't handle this type. If I can't handle this type, return null so that Moshi can continue looking for the correct adapter down the chain. If I can return it, then do all of my logic. And it's just a lot of boilerplate that as high-level application engineers, we don't really want to deal with. And so then we finally get to the implementation and the interesting parts. And this can be easily like just pulled out into this nice little class, or this value type really here, this constant. And we have these annotations that I'm going to explain why they aren't magic, and there aren't annotation processing, just at from JSON and at to JSON, and then we can implement all of that custom logic that we want. So what's really going on under the hood? When you're adding these JSON adapters, Moshi will actually just look up reflectively for the annotations on these methods, and then we'll actually create an implementation of a JSON adapter factory for you. So you pay a little bit of reflection cost when you're building your Moshi instance, but hopefully you're only building like one Moshi instance probably for like your application scope, or maybe a few. But hopefully it's not something you're doing regularly, and you're caching adapters. So it's not something you pay the price for much, and you'll probably never notice any difference. If you like are really concerned about reflection, then you can write out all the boilerplate, and or if you need more functionality, the JSON adapter factory, of course, is the all-powerful API. So here are the easy things you can do with the easier JSON adapter that's just like the basic class that uses reflection to create the factory. You can pass it in readers, you can pass it in delegates, and my favorite is when you already have a type that you know how to deserialize, you can just basically map it to that type, and then Moshi will create the implementation to be able to map to the type that you know how to deserialize already. which makes things really easy. And similarly, with going to JSON, there's these APIs, lets you do a lot of delegates. And if you already have a type that you know how to serialize, you can just map to that type. And also Moshi, if you accidentally create one of these methods incorrectly, so that's a little bit easy to do because, like I said, it's a reflective API. You're not like implementing an interface or anything. Moshi's just looking for these methods reflectively. Moshi will actually just tell you about all of these different formats that you can use in its error message. So if you accidentally get something wrong, Moshi's error messages strive to be really helpful. If they ever are not helpful, please raise an issue. Send a pull request ideally, but just raise an issue. And it's something that Moshi tries to be really good about. Helping you discover like what errors you might have made while developing. So polymorphic types are kind of that final frontier that I would say pushed Moshi to full feature parity with Gson. Moshi now is completely complete with its features to Gson. There really shouldn't be any hesitation in upgrading or at least with implementing all new code with Moshi. Polymorphic types, though, are handled a little bit differently and maybe a little bit more predictably. So what I'm talking about here are when this typically happens like when we have lists. We say my server is talking about animals, but it has a list of animals, and these animals are implemented differently. So I want to deserialize dogs differently than I want to deserialize cats. But they're all animal types, and I need to know how to deserialize based on like say in this example a field called type, and maybe that type says type has the value of cat when you need to deserialize as a cat, and a dog when you need to deserialize as a dog. So in Gson, here we'll see another part where Gson kind of likes to provide its own abstractions over Moshi trying to provide a limited API. Gson has this JSON element, which represents or basically contains a JSON object, a JSON array, and those are Gson APIs, a string, or a type of primitive, numbers, booleans, etc. Anything else that can be represented in JSON. Moshi has it just uses object. Your regular Java object, what you already know. And JSON objects are just maps. They're strings to other objects, which again could be any of these. And JSON arrays are just lists. They're just java.util.list, the interface, and strings and primitives. So what does that have to do with polymorphic types? The way that we do polymorphism in Gson is with this JSON element API, buffering the entire JSON element, and then knowing how to deserialize it. So as we're trying to read in our animal, we buffer the entire, so when we say here get as JSON object, we again forego, there's no other way to do this with streaming, of course, because we have to know the type field. So we forego streaming and buffer the entire object. So we have our JSON object, and then we say, if that's a cat, then I need you to delegate to the cat adapter. If it's a dog, delegate to the dog adapter, and then we can have our nice list of animals back in our response. In Gson, it's not too much different, but we just use maps. So read JSON value is basically that get as JSON tree. This will buffer the entire value as an object. Here we're asserting with the cast that this is a JSON object. It's like not a string, or it's not a JSON array, etc. And then we're saying if the map has this field with type that's equal to cat, then we need to delegate to the cat adapter. If it were a dog, we need to delegate to the dog adapter. But we probably, maybe we've never even written code like this, because Gson has this thing in this class in its example is called the runtime type adapter factory, which provides this nice API where we can add the types that we need to know how to deserialize, and we can say what like the base class is. Moshi doesn't have anything like this, and it's kind of because, again, it's not something that would go in the standard library, but it's something that maybe belongs in the examples, maybe belongs is actually a published artifact. The tricky thing with making it a published artifact is, like, again, we want to be able to hit that 90% use case. So for people who are going to use this, we want to hear, like, what your APIs look like. Do they have, like, some field, like in that last example, that's like type, and then you need to know how to deserialize it? What does that really look like? Is it going to be just like the runtime type adapter factory? I'm not really sure. It's like something that we want to have more use cases and understand better from the community. So updating piecemeal. So I've been talking a lot about like upgrading from JSON, and a lot of us maybe I'm not necessarily saying we all have to update from JSON. Like, obviously, millions of lines of code are written with JSON. A lot of Google's internal systems are written with JSON, and you don't necessarily need to update. I think as mobile developers, the performance optimizations might be compelling. I do think it's worth. I do think like writing new code should probably be done with Moshi. You want the latest and greatest. You want JSON 3. But if you are going to update from JSON, your existing application code from JSON, and you're using Retrofit, Retrofit provides a really cool hook into being able to do this kind of thing. So, as you might know, there are these converter factories in Retrofit that you can just say, hey, these are the types, and here's how you're going to deserialize these types. So these converter factories also provide an API that gives you the annotations on methods. And we can make use of that to be able to say, hey, new Retrofit services that we make, apply an annotation, like in this example, I've just made up an annotation called Moshi, and annotate those methods, and then when I want to, and then for those endpoints, deserialize those with the Moshi converter factory, and then fall back to, say, the Gson converter factory if we're using Gson or Jackson or whatever. And so the actual implementation details are here. There's a link. Jake also gave a talk, a couple talks. One of them was like at Ohio DevFest, I want to say, and where he kind of talks about more of the cool features of converter factories and why you should know how to use them. So, but this isn't a Retrofit talk, but that's a really cool way to be able to upgrade piecemeal. Auto-Value-Moshi Moshi is a thing. If you're an auto-value user, super easy to use. You can just provide that. So I want to provide some time to talk about Kotlin in a sec. So there, if you need to do it with all of your types, you can do there. For auto-value users. Okay, so Kotlin. Who here has at least like played with Kotlin, maybe? Who here has used Kotlin with the Kotlin JSON adapter in Moshi? Okay, so Moshi has this thing called the Kotlin JSON adapter. So it's a better way to be able to deserialize your things. With Kotlin, it'll allow you to do way more with Kotlin. The first thing that comes to mind when we talk about Kotlin, at least for me, tends to be nullability in the type system. So in Java, every type is nullable. There's no way to express that. Kotlin's great because it can do that. Kotlin's type system is a superset of Java's type system. And so we're going to see how that causes some problems that don't have a clear solution for Java libraries. But we want to see some cool things that Moshi can do with Kotlin. So let's say we have a data class and we have a default value for one of our properties. If you're not using the Kotlin JSON adapter, like if you're trying to use the Java class JSON adapter, then it's not going to know about default properties. It's not going to know what to do there. So if you're reading in like this JSON response that's now missing this cost field, your model isn't going to be deserialized the way you were hoping. You're not going to have that default value. But if you use the Kotlin JSON adapter, you've got this. It knows how to handle this. So that's really cool. And nullability, like I was saying, the Kotlin JSON adapter for basic things like this knows how to handle nullability. If we're trying to run in null into our name here for a non-nullable string type, this isn't going to deserialize. We're going to get a nice JSON data exception, and at least in 1.6. So if it's not an optional parameter, if we don't have a default value there, then we can't call into this constructor. So we're going to get a nice JSON data exception, and it's going to say I can't deserialize this type. That's great because now we don't have partially deserialized types like we did in Java. And there, if I provide like a default implementation, we have then we can deserialize like that. The tricky part here is that parameterized types. There's no easy way to know here that train is not nullable and let Moshi know about that. So the unfortunate thing right now is that if we have a JSON model like that and we have null in there, this is going to deserialize fine. And then at runtime, we go to try to access that, and we're going to say, hey, this is a non-null string. And then we try to access it, and then Kotlin goes, no, there was null in that list. And we're going to get a crash. We're going to get a null pointer exception. This is something that is a limitation currently. Finally, I want to say use it though, even with the given limitations. Figure out problems. Submit issues. Submit pull requests. Let us know what your use cases are. Hopefully, Kotlin again has like a lot of complexity, having a super type of the Java, its type system being like a super type of the Java type system, or a superset of the Java type system. So it has a lot of complexities. Let us know what you find. Let us know if error messages can be clear. I want to say add the Kotlin JSON adapter factory last when you're building your Moshi instance, because it will intercept all of your Kotlin classes by default. So if you try to add more factories for other Kotlin classes, those factories just won't be called. A nice way of doing that is just having an API that says like add it last, creating a new builder, and then making sure that that's always added last, so that in the chain that always gets delegated to. And finally, resources. Here's Jesse's write-up on Moshi and announcing Moshi as being fully feature parity with Gson being ready to use. And Jake has a talk on a few OK libraries, which is about OKIO and kind of the underlying types that like Moshi uses and OKHTTP uses. And finally, like ask all questions on Stack Overflow or find me after. Always happy to help. And get to using it in your new code and play with the Kotlin JSON adapter factory.